Hello everybody, it's Mike Levin on Thursday, July 28th, 2016 at about 5 p.m. and during lunch I said I was going to implement a cache for HTTP lookups, requests in the SEO notebook system, and so I have. I've done a little bit of organization on this file, adding a doc string, a framework for conducting SEO investigations using Google Spreadsheets for I/O. And there's a couple more imports in here, such as Shelve and requests, which will be global imports on main. And I added a couple of variables here, which were previously down here where the workbook was being opened, or the worksheet. And so it's easier to set your name of your file and your tab. And also there's now this cache equals true. And I put in a few more tries and accepts for things like HTTP calls and hits against APIs. So it's a little more fault tolerant. Although it's not very graceful in exiting, I'll just exit if the HTTP calls can't be made. And then I have extremely simplified the title tag. It's actually looking inside the row dictionary for a response object. It's grabbing the text out of there like the way it used to out of the response objects created by the request package that I was doing in here. But now the trick that makes this work, this caching, is that when it gets up to the last column of any given row, so that's what this is, it's reached the end of the row, so let's populate, that's a very special location. I blank the response object, or I blank the variable named response, just in case it's carrying data from the last loop. And I say if URL is in row dict, because remember, by the time you reach the last column, you now have an object that represents all the data from that row, and appropriately enough, a row dictionary. And I look for URL in row dictionary. You'll notice it's lowercase here, even though it's uppercase here. One of the things that I've done since the last time is I've added lower in the place where the function dictionary is being made. And I also did it where the column names are being added to col names right there. So everything is being looked up using the lowercase instances. It's a very common trick to not have to worry about case sensitivity. Everything is converted to lowercase as far as key lookups are concerned. Okay, so if it finds a column named URL in the row dictionary, then it's going to open a file, and I'll do a nice before and after here. We've got a little dictionary here, urls.db, that I'm going to delete. This is the before. That is the folder representing the SEO notebook project. This is the file I'm editing, but there are also these other files involved, such as Pipulate and Goodsheet, which are also in here. And there's also a few other files in the picture. But a new one is going to be urls.db, and that is the cache. Where does the cache come from? Well, right here in this line, with shelve.open URLs as URLs. Now I've got a open database, and I look to see if the cache is equal to true, and there's actually a URL piece of data in the keys of the dictionary. Okay, so the URL that we're on, the URL that's in our row dictionary, we look to see if it's one of the dictionary keys. And if it is, we just populate the response object with its contents. And this is actually technically unpickling. That response object is exactly the same type of response object in memory even with all the headers and cookie information, it's not just the HTML. It's the same as if you use the request object to do a request.get. So if you are caching and the URL that you're concerned with is in the dictionary, just grab that. Otherwise, it tries to do a request object get of that URL and puts it into the dictionary. And you'll notice because of the with shelve open, by the time it gets to that outdent, that is actually closed and it's all safe. So it spins through here, opens the database, does its thing, closes it. And before it closes it, it does this line here, which adds to the row dictionary the response object, whether it came out of the database or an actual HTTP call. And in that way now, functions can actually, just like they always did, pull in all parameters, but now instead of having the responsibility of doing all the HTTP work here just to get the title tag, it can just look directly into the response key of the row dict, and if you are parsing the HTML inside of it, the .text property, just like as you would if you had to use the request object in here. And so these functions, these Pipulate support functions, are going to be so incredibly terse, brief, and easy to read and useful. Unfortunately, this test I designed isn't exactly going to work because it's going to be trying to use the URL directly, and it's going to not be able to do the request action in here. So I will reconsider how I'm doing my testing, because of course every module can also be loaded as if it were main, and if it's running that way, it will execute whatever's in one of these if name equals main tests. So to get on with the demonstration, right? A lot of talk about what I've been doing. You'll see that Pipulate reports at the bottom here as it pipulates, and on the first go around it's actually going to take some time. Restart and run all, restart and run all. Okay, so what's going to happen? Pretty much just like it did before, it's going to do the pipulation process. Once it gets down to that location, oh, there, it's running. 1, 2, 3, 4, 5. See, so it's like that streaming output. And now it's reporting to you what row it's on. I was reporting cells before, but you can actually sit there and sort of in confidence know it's up to row 11, row 12, row 13, that things are going well. I believe Jupyter Notebook has a few issues here with asterisks because it clearly finished executing this block, but it hasn't updated that until this next block is finished. So that's probably like a bug in Jupyter Notebook, minor, but something to keep in mind. So you get the idea. Each time it's doing one of these rows, it's really invoking the true HTTP call of this one here. It's going through this path. Once that gets to 37, it'll be finished. And watch over here. Voila, all your title tags filled in. And you saw how long that took, and remember the before and after I mentioned. Here is urls.db. It came back, it was just produced a minute ago. Okay, so now let's blank these title tags and do that again and watch how fast it gets. Now that you have a cache, ho ho ho. Restart and run all. Bam! All your title tags filled in because it was all drawn from this little database. And you know, there's several approaches to overriding your cache now. You can simply set HTML to false, and then the path it'll run through, it'll still keep the caching files around, but it won't use them it'll get down to, let's see, if URL and row dict, so it'll still follow that. With shelves, it'll still do that. If cache HTML equals true, that will not evaluate true, so it will go down to here and do the actual HTTP call. I won't demonstrate that again because it takes a long time to get through all those rows, and take my word for it, that works. But another approach to clearing the cache is just clearing the cache, hitting delete, getting rid of it. It won't be there, and it'll get recreated on the next go around. That way, if you're doing work throughout the day and you're doing it over and over, and say you implement your title tag and you don't want to revisit the original page to extract different information, you can just extract it right from what you stored, because you can now write a description function here and refer to the response object that's in the row dictionary, just like that. And you could even get status codes to go back, see if it followed a redirect in order to fetch that HTML. All that data is still there, sitting on your hard drive, ready to be requeried. And of course, it just gets orders of magnitude faster on subsequent processing, so that's pretty nice too. Anyway, cache implemented. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.